Hi everyone, welcome to The Occulting Studio. I am making my first video here and I wanted to share um, some of the things that I've kind of done here. I wanted to help some people visualize with some of these drawings how um, how they how supposedly the sphere and the shape of the earth is supposed to be, and how it works by looking at it in a drawing. So I have this in AutoCAD, and I am going to show you basically the dimensions of it in feet. But there's also here some other scales that you can look at. So we have meters and we have miles. So those are the other units that we have here. And as you can see, we have the diameter in feet here. The diameter is 41,807, no, 41,807,040 feet from one side to the other side. And if we take that middle part, we have a radius, which is basically the extents of 20,903,520 feet. And that would be the same going from the middle to the edge. It's the same as going from this edge to this edge. So that makes sense. We have the radius in various different ways, and we'll come back to this because I feel like it's a critical point to look at. So let's zoom in here. And what AutoCAD is good for is that you can have kind of like a larger scale, and you can zoom in and still be able to draw to scale. So here we have a 200-mile line, we have a 100-mile line, we have a 50-mile line, we have a 20-mile line, and we go down progressively until 5 miles. And here we have the first mile. And what I've done is I've created a person at 6 feet right here at the bottom tangent, or at the bottom so let me regenerate here so you can see this is the exact point at which is like the tangent point. And that's what we have here. When I zoom out, we have this line that goes straight from there, and that's called the tangent line, which also becomes the extent of the radius. So when we zoom back in here, back into our scale, we can see that at 6 feet, when we go 1 mile, and I am going to put this dimension here, and as you can see, at the first mile, which is 5,280 feet, we have 0.6669 feet. So that's how much it drops in the first mile. And the second mile, we have a drop, and I'll regenerate this so you can see. It's 2.6674 miles or feet on the second mile. And then on the third mile, as you can see here, we have 6 feet. So on the third mile, we actually have the same height as the observer. Then we go to the fourth mile, and I'll regenerate here, and we have 10 feet. And then if I go to the 5th mile, at the end of the 5th mile, apologize for the sound in the background, we have 16 feet. And now we're gonna jump up to the 10-mile line, and we're gonna regenerate here so we get the line updated. And I will drop a line from the tangent line down. And now we're getting to, at 10 miles, which is basically 52,800 feet, we have 66.6839 feet. So at 10 miles, we have 66 feet. That's like as big as a 5-story building that it drops. So a whole building at 10 miles. And then here we have 266 feet at 20 miles. So at 20 miles, you should have already like a super big high rise. At 20 miles that it drops. And then at 50 miles, When you go 50 miles all the way down, we have a drop of 1,667.1556 feet, which is about 0.32 miles, which is basically a third of a mile drop. So think about that, a third of a mile drop when you look 50 feet out. And then here we have 100 mile, which is 264 feet. And I've seen Jay Tolan media go over distances this far when he's doing his photography on a plane. And so when we look here, I'm gonna go ahead and change the scale, and you'll see that at 100 miles we have a drop of 6669.4174. And then lastly, here at 200 miles, which is 528,000 feet, we have a drop of 26,690 feet. So if we take that and we go into Google, we go feet to miles, we can say 26690.4478 just to be accurate, and we see that that is 5 miles. So we can go in here and say, you know what, this is 5 miles. So when you're looking out 200 miles, when you're looking at 200 miles, you are looking at a drop of 5 miles. 5 miles. Like, I have a hard time running that. So yeah, that'll help you visualize a little bit of how the curvature kind of works and how drastic it gets once you go out this way. Now, the reason why 8 inches per mile squared doesn't really create a sphere is because what it does is it'll create a super steep, but it'll never actually go back and create the circle. But that one's just used to kind of visualize a drop. But this is the actual way that you would go about calculating the drop for a sphere, because eventually at some point, once you go 20 million feet this way, or once you go 4,000 miles this way, you already aren't drawing the sphere anymore. You have to come back around. So basically, you would use the equation for a quarter of it, and then you would have to kind of repeat it around. So it doesn't really make sense to me at all. And here I am now showing you that if we go from here, from the top to the side, is about 4,000 miles. And that's approximately the distance. If you look here, I went from Maui all the way to Louisiana, and that gave me about 4,000 miles. That would mean that this spot relative Louisiana relative to Maui, literally Maui would be here, and Louisiana would be here. And there would literally right now be a person in Maui, and I'm gonna rotate this object. So basically rotate the person. Okay, I'm gonna go back. You can grab that person and rotate. Because essentially what we would be doing is going out to here, and there would be a person in Louisiana standing over here. and it makes no sense, especially because we know that gravity is not a force, so there's no way that someone could be held onto a sphere. It doesn't make sense. So I just wanted to show you guys how this works. If you guys want a copy of this, I'll have it in the description. If you have any questions, please let me know. Please double check and make sure that these numbers kind of work out. And I'll be making more videos about this and other things related to de-occulting all these crazy things that everyone's kind of waking up to. So stay tuned. Thank you for watching, and look forward to making new videos and having you guys kind of engage with this information. Thank you.